Okay, so we have come to the most important segment of this conference. I'm sure you are enjoying all of the sessions, and going forward, the sessions are going to be celebration, fun moments, and a lot of engaging moments. So one such opportunity is going to come through our signature event, the PitchFest. PitchFest, okay? So as the name implies, this is an opportunity for startups to showcase their business, get the attention of Dunban Group or Dallas Venture Capital or other VCs and angel investors to raise money. And the reason I say this is a signature event of ATA and particularly the South Central chapter is due to the fact that we go through a very thorough process to select the participants. And once the finalists are selected, there are going to be 3 finalists who are going to actually showcase their business to us. So once we select, then they are being coached and their pitch materials are being curated by an eminent group of VCs. And with that, we believe that they are going to really do a stellar pitch today. And for the first time, this time around, the winner of this PitchFest is also going to be eligible for a cash prize of $2,000. And we want to thank the sponsor. Murthy is here, so he is one of the sponsors for this, so we are very thankful for that. So without much ado, I'm going to pass the baton to the lead of the PitchFest. We are very thankful to Mr. Adhavan Manikam, Venture Partner, Dallas Venture Capital, for helping lead the PitchFest for us. Adhavan, the floor is yours.
Thank you very much, Sriram. Vanakkam. Now we turn our attention to the very exciting pitch competition. As Sriram said, this is going to be one of the more fun aspects of today's agenda. We have 3 wonderful and exciting startups that are going to pitch their companies today. And as Sriram mentioned earlier, we have helped them curate their pitches, and hopefully you'll all find it very interesting and engaging. We have a panel of 4 judges. I'm just going to quickly introduce them one by one. First is Ram Sridharan. He's a fellow at Dallas Venture Capital, along with myself. He is a veteran in the telecom industry, 25 years, more than 25 years of experience. He was a field CTO at Nokia, and currently his area of focus is cybersecurity, and he's helping us curate some of the companies at DVC in the cybersecurity area. And the second judge would be Dr. Bharat Rayasam. Bharat is an information technology veteran with more than 25 years of experience. He has worked in companies like Blockbuster, JCPenney, Sabre, and Intuit. Currently, he is the co-founder and CTO of iDocsWeb, a telemedicine-based healthcare company. His experience is in digital transformation, product innovation, and user experience. And he has brought all of them together at iDocsWeb. Dr. Rayasam has a doctorate degree in electrical in engineering, I should say, from Clemson University, and also an MBA from IRMA, the Rural Management Institute from Ahmedabad in India. And he's also served as an adjunct professor at UTD right here across the street. The third judge would be Mr. Gurumurthy. He's a successful first-generation entrepreneur who co-founded Virtual Tech Gurus, VTG, a company that has been recognized as one of the SMU's top 10 fastest growing companies, and has received several Inc. 5000 awards. In addition to VTG, Guru has launched Zenfra, a multi-cloud infrastructure analytics and cybersecurity auditing platform that is used by many companies. He's also co-founded Cloud Tech Services, which provides employment opportunities for rural and women entrepreneurs and workers, while meeting customer needs in networking and telecommunications. And finally, we have Kutral Ramesh. He was already here earlier, if you guys been around for the whole whole of this program. And he doesn't need any more introduction than we already gave him earlier. But he's been with Nanban Ventures, and he's a very accomplished venture capital person in the venture capital industry. So he's going to be our fourth judge today. And from the pitch perspective, we have 10 minutes for each competitors here. They'll do a 10-minute pitch, and then we have about 5 minutes of Q&A from the judges. For the audience, yes, you can interact with them too. We will have a QR code up on the screen where you can, take a picture of and interact with and send your, comments and questions and so on and so forth with individual competitors here. So with everything said there, I think the companies are ready to go and pitch, and I don't want to stand in the way anymore. So the first competitor would be Hemato.AI, and the co-founder CEO, Vinodhbalaraman, will be presenting. Vinod? Oh, please, judges, can you take a seat out here right in front of the stage?
Okay. Hopefully the technology is all set. We're here to talk about Hemato.AI. Hemato for blood, hematopathology, hematology, you might have heard that. My name is Vinodhbalaraman, and I'm the co-founder and CEO. We'll just quickly run through a few things, intro, the problem we're solving, size of the opportunity, competition, plan of attack, traction, and so on. Okay, let me start with the introductions. I'm from Chennai, so that's the ATEA connection. IIT Madras, Padma Zeshari, Baladaran High School, IIT Madras undergrad, then went to Purdue University for my master's in industrial engineering, and then MBA from University of Chicago Booth School. Over the years, my background has been as an executive leading and building multiple technology-enabled businesses, particularly in the healthcare space. I was previously a senior partner at ZS Associates, which is a leading life sciences strategy consulting firm. I led the data science practice and the supply chain practice for ZS. I also was a senior vice president at Atos, which is like one of the large tech consulting services firms. I led a $1.4 billion business for digital technologies. I've advised and mentored various startups in the healthcare space, based out of New Jersey, and I flew just for this event, so really pleased to be here to meet all you guys. My co-founder is very deep medical experienced folks. Dr. Ali Moini is an MD and a data science expert mixed into one. It's a very rare combination, and we need a uniquely crazy person like him for a startup like ours, right? He's our CTO. Dr. Sasan Zandi is an MD, head of hematopathology at the University of Toronto. Aaron Cox is our co-founder, chief of product. We have a couple of esteemed advisors, Dr. Motahar Hosseini, who is double-board vascular surgeon at Mayo Clinic, helping us with our clinical algorithms, and Uday Srikanth, who is a deep technologist. He's the CTO at TerraTrue. The only point I'll make here is our leadership is very, very complementary and addresses all the key elements needed for a startup like ours. So we cover the clinical science and hematopathology component, the engineering and AI dimension, product design and development, and business development and go-to-market strategy. So what are we? So we are addressing the core problem, one of the core problems in medicine, which is the fact in hematopathology, it's the peripheral blood smear study, which is the foundation of it, is an extremely cumbersome, manually intensive process that people have to go through. So where that fits in is the following. So most people are probably familiar with the CBC, or complete blood count test. Those are done as part of any typical physical, and they're done by these automated analyzers. So that's pretty standardized stuff. except that the CBC yields limited information. It does counting of your blood cells and platelets and so on. A certain proportion of the CBCs, when they suspect something deeper based on the CBC output, they refer that for an elevated study called a peripheral blood smear study. Okay, that's about 15 to 20% of CBCs are referred for this. The PBS, I'm going to refer to it as PBS study. The PBS study has to be done manually by an expert pathologist looking through a microscope at the image of your glass slide with your blood on it, right? That's the only way to do it today, and because of its very nature, it's a cumbersome process. It's expert intensive, effort intensive, can take up to 30 minutes of time from the hematopathologist. That's where we come in. We're a deep science play, and our innovation is really that we've completely automated this peripheral blood smear study. So we take the image of the blood slide as an input, and we automatically diagnose the full list of differential diagnoses from that, right? And we write up a pathology report indistinguishable from an expert pathologist write-up. That's what we do. We use AI and clinical algorithms that we built in a proprietary language. Obviously, our technology is very low cost. It's just it's pennies to run every study, and it's super fast. It can do it in seconds, something that would potentially take several hours to several days. And it can be used anywhere in the world where you have internet access. Nobody else is doing this. Currently, there's no direct competitor to what we're doing. We're targeting to be the first to FDA approval, and in parallel developing our customer base. And in fact, we've identified and secured our first 2 customers with some revenue expected later this year. I'll touch on that. This is the schematic. I'll be quick. So the patient goes to the attending physician, gets the blood draw. That blood goes to the blood analyzer machine, which is a CBC machine that I referenced. A certain proportion of those are referred for the peripheral blood smear study. That's when they make a glass slide, and then they digitize it using whole slide imaging scanners. The traditional process is it goes from there to the right. You'll see it goes to the technologist, who does the triaging of the work before it goes to a pathologist. So all these labs employ large armies of technologists who do all this initial work of screening before it goes to a pathologist. And then it goes to the pathologist who looks at it, does the diagnosis, writes up the pathology report, goes to the attending physician. So what we've done is we've obviously circumvented the right-hand side with our AI-based intervention. So we're taking the digital slide as an input, we're writing the pathology report, goes to the attending physician. The addressable market is very, very large and untapped. There's 2 major use segments. Okay, so I'll keep this very simple. There's the clinical use segment. So this means we can be used as a diagnostic test in treating a patient. Okay, so this segment is really clinical labs and hospitals with labs and clinics. It's about $17 billion a year globally of addressable market. The second big segment is the research use segment. This is about $7 billion a year for research. Think of it as where we can support the research, R&D being done by biopharma companies in developing drugs and for other medical research, right? The one notable thing here I'll mention is most of these research use cases do not require FDA approval. So these are, in fact, the very first customer we've secured is Washington University School of Medicine. It's for a research project to develop a new diagnostic for myelodysplastic syndrome, which is a kind of cancer. So the total is $24 billion a year of addressable market. This is a quick comparison with alternative approaches. The easiest way to read this slide is, think of us, we provide all the advantages of manual microscopy shown on the right-hand column, minus the disadvantages. So in other words, we are a true general purpose diagnostic. We fully diagnose disease except we do it in a fully automated fashion, so we can do this in a matter of seconds at almost no cost without depending on experts. These 3 columns in the middle cover some other digital pathology technology companies. Typically, none of them will do diagnosis. Okay, the furthest they will go is in terms of doing decision support tools to aid a pathologist, but not a full diagnosis. Mostly they don't play in hematopathology, they play on the anatomical pathology space. Some of them are hardware dependent, and none of them are general purpose. They usually are custom. They focus on a particular disease, right? So the competitive advantages are simple. There's 6 major things I'll touch on. So number 1 is the fully automated delivery of differential diagnosis. So we can actually tell you the diagnosis of disease. Number 2 is that we're truly general purpose AI, right? So we are not a custom diagnostic for a particular disease. We can cover the full range of diseases looking at a glass slide. Number 3, no dependency on proprietary hardware. Number 4, focus on hematopathology. Number 5, we handle raw untouched images. And we also have a proprietary fully annotated data set of peripheral blood smear images. I'll keep this very quick. The plan of attack, we're going for FDA approval for 3 diagnoses. In parallel, we're deploying our go-to-market strategy to develop our customer base. We're attacking the research segment, which does not require FDA approval. We're also going after the clinical space, but focusing on triage, which is that first step I talked about, automating the technologist role, which has much lower cultural resistance. Of course, getting to the pathologist and eliminating that work is the next goal. We are partnering with key channels to be the AWS of diagnostic API. What I mean by that is, to enter these clinical labs and hospitals, we're partnering with hematology device manufacturers, and we're also partnering with digital software technology platforms. Digital pathology software platforms. Subsequently, we'll get the FDA approvals for all the additional conditions. So the idea is in 5 years, we will cover the full range of conditions. There's about 200 diseases you can identify from a peripheral blood smear, and we'll cover all of that. I'm going to just finish very quickly here so we can get to some questions. There's traction with 2 key customers. Okay, so one is the Washington University School of Medicine. We've identified a project to develop a new diagnostic approach for myelodysplastic syndrome. The other one is a large global device manufacturer. In this case, it's Bosch Healthcare. They have a hardware device which looks at the blood slide and produces a digital image, and we will be the software that plugs in as an API to that, and we'll do the full diagnostic report, so it becomes an end-to-end play. We've completed the AI technical MVP, created a data set, annotated PBS, and the FDA process is underway. Right? We've gotten good positive feedback from the FDA. We're raising $2.5 million in seed money. Using SAFE, this will cover us for 2 years to the FDA approval for 3 diagnoses that I talked about, plus building the SaaS product, which is that engineering and development component, and finishing up our data set, which is the data collection and expert validation part. And this is the last thing. I mean, this is a SAFE, valuation cap 10 million pre-money. The comparables are 22 million through late last year, so we've gone in at a lower value to incentivize early investors. And the relevant benchmarks in this space are very significant. You can see median Series B is 10 times to 40 times the seed value, right? So I'll stop with that and let's go to questions. Yes?
So this is very exciting.
Thank you.
My question is, I know you must have touched it briefly. Use the mic. You must have touched it briefly, but can you be more clear on what problem are you solving? Is it the process improvement, cost savings, labor savings?
All of those, yeah.
And who is your customer or set of customers?
Yeah, so it's all of those, right? So the current process for peripheral blood smear study is a very cumbersome process, right? It has to be done by an expert hematopathologist looking at a glass slide through a microscope. So obviously it takes multiple days. Sometimes it's costly, $30 to $100 a slide, and it requires an expert. And these pathologists are in very short supply. So if you talk to any doctor, they'll tell you the biggest shortage is on pathologists, particularly hematopathologists. Okay, so we're addressing all of those issues, right? So we're doing this with AI. So we can do this in a matter of seconds. We can do this at almost zero cost. It's literally pennies per slide versus the $30 plus per slide that the human approach uses, and no
how
expert.
does the accuracy compare? Something done manually versus
Yeah, it's pretty good. I kind of skipped over this because of time. So we're getting 95% specificity and 85% sensitivity with the available data. The specificity is pretty important. It means if I say this is malaria, it is malaria. Okay. The sensitivity is about the range of things we can cover. That's related to the amount of data we have. As the data set gets larger and larger, the sensitivity started at 70%, it's already at 85. We're pretty sure it's going to get to 95. Okay, so, and this is the type of range you need, to be better than it's much better than human experts. And don't forget, AI is not subject to mistakes. Like, once you train on something, it doesn't make negligence mistakes like human beings, right? So that's the advantage.
So adding to that, I think it's a great product and it's solving a real world problem. I think we all need it, like we all need a report so quick.
Yes.
So that being said, I think there are two areas I'm looking at. Okay, what's your customer acquisition strategy? I know like you have a lot of customers. I think that's something I didn't see in detail here. And follow on to that, I think the OpenAI, ChatGPT is like, it's creating a lot of noise in the market. That means it's so many moving parts here. How your product is going to be, I looked at the timeline, how are you going to compete, or how are we going to compete in the timeline wise and also in the features wise against those products?
Yeah, so the first one, the customer acquisition strategy, this is the, go-to-market strategy part, right? I went over this a little bit quick, but the strategy is the following. Right now, as we're going for the FDA approval, we're focusing on these initial use cases that do not need FDA approval, which is all these research use cases, like biopharma and medical research. So that first customer I mentioned, the Washington University School of Medicine, is a classic example. We're doing a research project to identify a new diagnostic for myelodysplastic syndrome. In addition, we're also going after the clinical space, but focusing more on triage. The triage is that initial technologist step, which does not require a pathologist. It will still need to get signed off by a pathologist, okay? But we can take away 80–90% of the work if we do the triage, and there's less cultural resistance, right? So labs are much more open to talking to us about that. The greater resistance is on replacing the pathologist, right? So, yeah.
And adding to that, I think I interact with a lot of like in healthcare, like insurance executives. Like that being said, I think a lot of those companies are shying away from AWS because AWS is trying to get into the healthcare, all this problem market. I saw one of your approaches going with like AWS APIs.
What we're trying to say, I'll clarify what we're trying to say. What we're trying to say is we are going through these channels, okay, like hematology device manufacturers and digital pathology software companies. Just like AWS goes through all these system integrators, right? But everybody wants AWS, but AWS doesn't directly go to any company. They go through all the SIs, right? So we're using a similar approach. We're saying we will be the AWS of diagnostic API. So we will partner with these players, who then go into all the labs and hospitals. And our Bosch Healthcare, the second customer I mentioned, is a perfect example of that, right?
Thank you. Vinod, sorry, I have to cut you off.
Any questions?
Yeah, could you hold the question for the end of the session, please? Because you have two more companies to go through. And it's a little award for you for being a finalist.
Thank you.
It's a little award for
Appreciate it.
Vinodhbalaraman.
Oh, okay. Can I open it?